Welcome to the Navy channel. In today's video, we're exploring the fascinating world of aircraft takeoffs and landings on aircraft carriers. We'll cover the technology behind these complex maneuvers, including the electromagnetic aircraft launch system EMLS and its deployment on various aircraft, as well as the intricacies of vertical landings like those performed by the F-35B Lightning II. Let's dive into the details. Aircraft carriers are engineering marvels that serve as floating air bases, projecting power and providing crucial air support for naval operations worldwide. Launching and recovering aircraft on these moving platforms is a sophisticated process that involves cutting-edge technology and precise teamwork. The flight deck of an aircraft carrier is the heart of all takeoff operations. It's coated with a non-skid material to provide traction for aircraft and personnel and marked with various lines and symbols to guide pilots and deck crew. Traditional aircraft carriers use steam catapults to launch aircraft. These systems have been in use since the 1950s. The steam catapult consists of a large piston that runs along a track on the flight deck. Steam pressure builds up in a chamber, and when released, propels the piston forward, pulling the aircraft with it via a shuttle and tow bar. Modern aircraft carriers like the USS Gerald R. Ford have adopted the electromagnetic aircraft launch system instead of traditional steam catapults. Naval uses electric motors to generate a magnetic field, which propels the aircraft along the track. This system provides several advantages over steam catapults. Naval offers more precise control over the launch, reducing stress on airframes and allowing for a wider range of aircraft weights to be launched. The system is more efficient, requiring less maintenance and fewer crew members to operate. Emails delivers smoother acceleration, reducing wear and tear on both the aircraft and the carrier deck. The F-A-8 Super Hornet, E-2D Advanced Hawkeye, and the F-35C Lightning II are some of the aircraft that utilize the EAM technology for takeoffs on modern aircraft carriers. A well-coordinated carrier can launch aircraft at an impressive rate. For instance, during peak operations, an aircraft carrier can launch one aircraft every 20 seconds, equating to 3 aircraft per minute. This rapid launch capability is crucial during combat operations when quick deployment of air assets is necessary. For landings, aircraft use an arresting gear system. This consists of steel cables stretched across the flight deck, which aircraft hook onto with their tail hooks, rapidly decelerating them to a stop. The landing process is often referred to as a trap. The arresting gear system includes several steel cables known as RR wires stretched across the flight deck. When an aircraft lands, its tail hook catches one of these wires, bringing it to a stop. Modern carriers use a system called the Advanced Arresting Gear AAG, which is more efficient and provides better control. During the landing process, AAG uses energy absorbers and digital controls to adjust the resistance, providing smoother and safer landings for a variety of aircraft types. The F-35B Lightning II stands out among carrier-based aircraft due to its short takeoff and vertical landing STOVL capabilities. Unlike other aircraft that rely on catapults and arresting gear, the F-35B can take off from a shorter runway and land vertically, making it highly versatile and adaptable for different types of ships, including those that do not have catapult systems. Short takeoff: the F-35B can take off from a shorter runway by using its powerful Pratt and Whitney F-135 engine and vector thrust. This engine is capable of producing 40,000 pounds of thrust, allowing the aircraft to achieve the necessary lift in a much shorter distance compared to traditional fixed-wing aircraft. This capability is particularly useful on smaller carriers and amphibious assault ships. Vertical landing: for landings, the F-35B can hover and descend vertically thanks to its lift fan and swiveling exhaust nozzle. The lift fan is driven by a shaft connected to the engine, providing additional vertical thrust. The exhaust nozzle swivels downward to direct the main engine thrust vertically. This design allows the F-35B to land like a helicopter, eliminating the need for arresting gear. This capability is invaluable for operations on ships with limited deck space or in environments where traditional runways are unavailable. Technology: the F-35B's Pratt and Whitney F-1335 engine is equipped with a 3-bearing swivel module that directs thrust downward for vertical takeoff and landing. The lift fan located behind the cockpit provides up to 20,000 pounds of lift, balancing the aircraft during vertical maneuvers. The integration of these systems allows the F-35B to transition seamlessly between conventional flight and vertical landing. Operational flexibility: the stove capability of the F-35 B provides significant operational flexibility. It can be deployed from smaller carriers and amphibious assault ships that lack catapult and arresting gear systems. This makes the F-35B an ideal choice for forward-deployed units and expeditionary forces. The ability to operate from a variety of platforms enhances the Navy and Marine Corps' operational reach and responsiveness. Training and precision pilots flying the F-35B undergo extensive training to master the unique flight characteristics of STOVL operations. The advanced flight control systems of the F-35B assist pilots in maintaining stability during vertical takeoff and landing, ensuring precision and safety in challenging conditions. A typical aircraft carrier can recover land one aircraft approximately every 45 seconds under optimal conditions. This means around 1 to 2 aircraft can be landed per minute, depending on the operational tempo and the skill of the deck crew. Operating aircraft on carriers presents several challenges. Here are a few key ones and how they are addressed. The flight deck is exposed to the elements, and wind conditions are critical for safe takeoffs and landings. The carrier adjusts its course and speed to create optimal wind conditions across the deck. The movement of the ship due to waves can complicate landings. Advanced stabilization systems and precise timing help mitigate these effects. The flight deck is a crowded and busy place. Efficient coordination and communication are essential to prevent accidents and ensure smooth operations. The risk of accidents is high due to the nature of the operations. Comprehensive training, strict safety protocols, and continuous vigilance are crucial to maintaining safety. The technology and operations involved in aircraft takeoffs and landings on aircraft carriers are truly remarkable, from the traditional steam catapults to the advanced emails, and from the arresting gear to the unique capabilities of the F-35B Lightning II. These systems ensure that aircraft can launch and recover safely and efficiently. The dedicated deck crew and advanced technology work in harmony to make this possible. What aspect of aircraft carrier operations surprised you the most? Let us know in the comments below. Thank you for joining us on this deep dive into the world of aircraft carrier operations. If you enjoyed this video, please subscribe, and hit the bell icon for more fascinating insights into naval technology and operations.